Traditionally, computing was classified into general-purpose computing, performed by general-purpose processor, GPP, and application-specific computing, performed by an application-specific integrated circuit, or ASIC. General-purpose computing was first accomplished by the electronic general-purpose computer called Electronic Numerical Integrator and Calculator, ENIAC, but it is well known as von Neumann computer because ENIAC was improved by John von Neumann. A general-purpose computer is a single common piece of silicon called microprocessor, or GPP, that could be programmed to solve any computing task. This means many applications could share commodity economics for the production of a single integrated circuit, IC. This computing architecture has the flexibility and superiority that the original builders of the IC never conceived. An ASIC is an integrated circuit specifically designed to provide unique functions. ASIC chips can replace general-purpose commercial logic chips and integrate several function or logic control blocks into one single chip, lowering manufacturing cost and simplifying circuit board design. Although the ASIC has the advantages of high performance and low power, its fixed resource and algorithm architecture results in drawbacks such as high fabrication cost and poor flexibility. As a trade-off between the two extreme characteristics of GPP and ASICs, reconfigurable computing has combined the advantages of both. A comparison among the characteristics of the three different architectures can be seen in this graph. On one hand, reconfigurable computing can have better performance with respect to software implementation, but paying this in terms of time to implement. On the other hand, a reconfigurable device can be used to design a system without requiring the same design time and complexity compared to a full custom solution, but being beaten in terms of performance. Further, the performance of reconfigurable system is better than general-purpose systems, and the cost is smaller than the one of an ASIC. Only recently, the power consumption of reconfigurable systems has been improved such that it is now either comparable with an ASIC or even smaller. The main advantage of a reconfigurable system is its high flexibility, while its main disadvantage is the lack of standard computing model. The design effort in terms of non-recurring engineering cost is between that of general-purpose processor and ASIC. Considering that we were looking for a definition closer to the actual status of reconfigurable technologies, this scenario is bringing us to the definition of what a reconfigurable computing is, according to Christoph Bobda. He was defining a reconfigurable computing as the study of computation using reconfigurable devices. That's great. But still, we are quite blocked in a loop. Without knowing what a reconfigurable device is, we cannot fully appreciate the definition of a reconfigurable computer.